Hello all. We have previously seen how to start with a simple project in the Blinky LED project with EFM32, right? So in this video, we will just go into details of the microcontroller to get to know what this microcontroller is and what are the basic features, so that we can explore these features uh, by writing a small code or whatever. So again, as we mentioned, there are several example projects and demos available. So if you are a student or a beginner, you can use them, play around, understand the code. Or if you are a professional, you can start writing your code from the scratch by going through the data sheet and the reference manual. So let us just try to open the data sheet. So if you see, this is the EFM32 Giant Gecko Series 1 family data sheet. So if you see the data sheet, you see that this is the world's most energy-friendly energy-friendly microcontrollers. So how they claim that is basically based on the power consumption of the microcontrollers. And one thing, if you see on the left here, in the energy mode 0, that means this full active state, the consumption is 76 microamps per megahertz. This is very, very low. Actually, we'll just open the MSP 432 datasheet. If you see here, the MSP 432 from Texas Instruments is 8 grams per megahertz. So, that's in the active state. So here you can see here it is 76 micrograms, which is claimed as ultra low power consumption. So in this segment, Silicon Labs EFM32 controller competes with the Texas Instruments microcontrollers, and then the ultra low power microcontrollers, the XLP devices from Microchip. So you can go through those and compare. But EFM32GG12 is definitely one of the best in this segment. It has several features. So if you see the basic applications, you can see here the major application is the IoT devices. So considering the IoT applications, considering the energy efficient wearables and other automated related applications that we see in the market today, EFM32 would be one of the choice for them. So considering keeping those scenarios aside, definitely we are saying EFM32 is one of the best microcontrollers when we come to the power. Now if you look at the features, it has a octal quad SPI, which is common among the microcontrollers, and then it has STMMC SDIO host controller, which can be used to interface the SD card. And then we have talked about the PDM microphone sensor interface when we talked about the board in the first video. So this is a microphone interfaces with PDM interface. And then it has a dual CAN 2.0. So now you need to go through the data sheet and see if both the CAN you can use or only single CAN, because if you have the EFM32 Thunderboard in your hand, it is only a 64 pin QFN package microcontroller that is present, whereas in the same EFM32 Giant series you also have BGA packages, which crosses 100 plus pin count. So you check out whether from this particular datasheet which we have opened, you can check out whether particular interface is supported or not. So that's in the hands of the designer, who has to thoroughly go through the datasheet. And then again, this is a low energy USB that is there, and crypto CRC related encryption related features are there. And this is one more robust capacitive touch interface. So there is a capacitive touch interface And then there is a footprint compatibility between selected EFM32 packages. That means, example, if you have used a particular EFM32 in your application and suddenly that particular device has gone EOL due to specific features or based on demand, you can opt for another EFM32 with the same footprint compatible option, which is a very, very good feature, right? So practically, if you are using EFM32, that means you have that freedom to uh, use any EFM32 package. Definitely, there will be some power related changes, or we need to do those calculations in the background and then select that EFM32, and then you have a 5-volt tolerant IO. That means the IO, even though this microcontroller works at 3.3 volts, the input pins, IO pins of GPIO pins of the microcontroller are 5-volt tolerant. So that's one more important feature. So this, if you see here, is the block diagram, and if you see here, EM0 is active mode. So that's what we have talked here. EM0, the energy mode 0, which is active mode, and which we have seen in the MSP432 as well. So base, you can see this particular marking, whether it is green or blue, you can see here specific interfaces will be available. Like example, if you see EM4 is shut off, which is the lowest power mode, right? There will be only general purpose IO. Okay, there'll be only pin reset, pin wake up, and cryo timer. Cryo timer means this is a timer which is used in low power modes to enable enable at the microcontroller at specific intervals rather than being powered on. And then you can see here at same point you can use either of these: low frequency crystal oscillator, these are internal, low frequency RC oscillator, low frequency, ultra low frequency RC oscillator, and then all these features are available. So based on the marking, you can understand, and these are the internal blocks of EFM32. So in the EFM32, as we mentioned, there is a Cortex M4 processor with floating point unit, and definitely, as this is a microcontroller, it has internal flash memory and RAM. The flash is 1024 KB for the device we selected. We'll just go through that in the next slides. And then the serial interfaces you can see here, UART, CAN, and definitely the memory interface, PDM, which we talked, and quad SPI. This is the USB, low energy USB, and then low energy UART, and then I2C. So you can see the marking here, the interfaces which are available at different options. So active mode means you have the controller and everything, the core and everything active. In the sleep mode, you will have only specific interfaces active. So you need to go through the active mode, sleep mode, where you need to keep your microcontroller so that you have the lowest power consumption. So based on your applications, you need to do that. So example, if you are using this microcontroller in a specific application, and you want to enable, you want to read a data in the field at a specific time interval, and at the other intervals you need not have the microcontroller powered on. So in those cases, like example, that can be one IoT case where it is used in the field. So you can keep the microcontroller active, and then you can take right down to the shut off mode, and you can save a lot of power. So there are IoT devices in the fields which work for 3 years or more with a simple coin cell. So this could be one of the option, but again, we need to do a lot of power calculations for that. You can try it out and see the quiescent, considering the quiescent currents on your board. So ultimately, even the microcontroller supports the board design that you do should support the low power operation. So if the microcontroller doesn't draw, it doesn't mean your circuitry around it doesn't draw. So you have to design your circuit properly, and you have to select your devices such that you have very low quiescent currents, and also you plan your power management on your board such that you get a lowest power possible out of your board. And now this is the going back to the block diagram. This is the core. This is the clock management. Clock management has for any microcontroller, clock management has features of PLL, where it generates the clock for further peripherals, and then you also have the internal oscillators that are available, which can be used if you don't want to use an external oscillator. And then the energy management feature definitely, main feature is the internal DC-DC converter, which generates the 3.3 volt required, or the required rail for the microcontroller internally. And then the power on reset and backup domain related features will be part of energy management. And definitely this is very important. If you have a very less power consumption board, a small board that need to be designed, and you don't want to use an external LDO for your application, and if you just want to take some 5 volts and generate the required rails, this is the one to go. And you save a lot of cost as well, because you need not add an additional LDO outside to generate the 3.3 volts for the microcontroller. And then crypto engine, there's an CRC which is part of it. And then we talked about the serial interfaces, the IO interfaces. So if you remove all others, one important point is pin wake up. So this is very important. So KFN 64 has 51 GPIOs, so we'll talk about it. And pin wake up is very important. What does this pin wake up do is, in a general perspective, when you have a particular pin, so you can have that microcontroller in sleep, and based on any external toggle that happens, toggle in the sense like a edge trigger, it could be going from high to low or low to high, and based on that you can configure your wake up pin, and the microcontroller can come out of sleep condition, and it can go to the state which you have defined. So this is used in the case which you have talked before, where you want to read either based on enabling the microcontroller at specific intervals, or waking up only when there is an external interrupt. So very useful. And then timers, triggers are common, which are used in which are present in every microcontroller. So one additional thing is low energy sensor interface. This is a very important thing. And in this particular microcontroller, we have something called LE sense. So if you get, so we will see in the next slide, or you can see here LE sense. So LE sense, low energy sense. So this is a particular interface where you can read where this can sense the current, and then like example, if you have a big coil which is passing, which is having a lot of current, and then if you keep this coil near this particular LE sense, it can sense and convert it into a voltage, and see and detect, like example, to see if the current is flowing or not. So we will talk about that application in detail. That's a very basic introduction we have given. So we will talk about that. And then definitely the analog interface. So this particular microcontroller has 12-bit VC, and it also has capacitive sensing, and it has LCD controller as well. So very good features, comprehensive features that are present on this board. So the maximum that you can use depends on the configuration of the chip that you select. For example, as we said, whether it is QFN64 or QFN or a BGA package. So the main one more important thing, while selecting the microcontroller, you need to have a grip on the configuration of the microcontroller you have selected. So if you see the FM32 series, there are number of microcontrollers present. So based on the number of microcontrollers, you select the one appropriate based on its part number. So if you see here EFM32, it's you can see energy friendly 32-bit microcontroller. G is Giant, G is Gecko, and then one means series one, two is the device configuration. So B is performance grade. What's the grade? Apart from this, if you our most interest is on this the flash memory 1024 KB, and then the temperature grade at which you want to select, and the pin count. So if we just go back to our part, you can see here FM3212 810F. From here, if you see 1024 GM64, 1024, okay, 1024 G is minus 40 to 85, M is QFN package, and 64 is the pin count. So that's how you differentiate. So if you are a beginner, you need to go through this is called an ordering part number. Like example, if you are selecting an application, selecting a microcontroller for your application, you need to understand which part number need to be used. So in the data sheet, you can go to the ordering part number and then select the microcontroller and use it in your application. So for if you are using an evolution board, you need not bother much, because that is already part of that board, and you just need to use it, understand the features. But if you are designing a new board and if you want to select a microcontroller, for beginner, this is very important to understand. And then if you go to this, so this is a system level block diagram. Again, it's the same what we have seen as internal block diagram, but these are the pins which extend out of this particular EFM32GG12 microcontroller. Previous one we have seen the internal block diagram. This is with respect to external interface, and you can see here these are VBus, that means the USB related, and then the input power supply and the monitoring that happens, and then internal DC-DC converter. All are called a energy management block. And apart from that, you also have reset pin, which is going to the core, the reset management unit, and then you have the JTAG signals, the debug programming, which again goes to the core, and core has 1024 KB of flash and 192 KB of RAM. So this is very important, and it has a floating point unit option as well. And then the watchdog timer and clock management. So as we said, there are several features of clocks that we have seen in the first page, where we talked about high frequency crystal oscillator, high frequency RC oscillator, PLL, universal HFRC oscillator, auxiliary frequency oscillators. All these are different oscillators based on the frequency ranges, based on the the type of oscillator and its power consumption related options. So if you see the clock management, in this you have two major points to see. You can either have an external crystal, or you can use an internal oscillator. So the major difference is, if you are new to the microcontroller usage, or if you are new to connecting these kind of oscillators, if you don't need too much of stability of the clock, if you are okay if there is a slight variation, very slight variation. When we say variation, it's not too much, and you don't need exactly a stable clock, then you can use an internal oscillator for different ranges of clocks. But if you need a stable clock, and yours is very time critical application, then definitely you go for an external clock. So that is the basis, whether to use an internal clock or external clock. So to put it the other way, the internal clocks of microcontrollers that are available in the market will have a very high ppm variation per degree centigrade. So that means based on the temperature, the frequency is going to vary slightly, which is not desired, right? So, and then if you go to the digital peripherals, all these peripherals are available through the ports A to F. So which again, based on the pin mapping of a particular microcontroller, we need to understand that. So, but this is very important. As we mentioned, we have the 12-bit ADC, which is internally present, which can be used to read the external sensor values, and it also has a DAC, which provides a digital analog output based on the digital input. So there's a digital to analog converter which is there internally, but we will talk about those features when we use the actual microcontroller, and then we will see the actual pinout. So if you go to this pinout KFN64, this is what we are using, right? So you can see here there are 64 pins that are available, and you can see most of them are right now shown as with a port number P0, P15 kind of. But example, if you take PA0 pin, so PA0 shall have many functions which basically called multiplexing. So in a microcontroller, you cannot with a just a 64 pin, you cannot have all the features on all the pins, right? So there is something called multiplexing that happens in microcontroller, where each and every pin will have multiple functions. So you need to understand which pin has that multiplexing function, and you need to configure in the firmware such that the pin acts as per your requirement. Like example, I think there is a sheet which mentions multiplexing operations. Yeah, so if you can see here, this is the functionality table, the GPIO functionality table. Example, if you take PA0, PA0 has these many functionalities multiplexed with it. Now, example, if you want to use this pin for I2C0 SDA, okay, so that means you have a configuration that need to be done in the register of the microcontroller, enabled in order to configure this PA0 as I2C SDA0. So you have to look at the reference manual for this particular microcontroller and configure it as IDC I2C0 SDA, and then only you can, this pin acts as I2C. Otherwise, by default, we need to just check once. By default, these GPIO, these pins act as a GPIO, and there's one more table. You can see here, this is the alternate functionality overview table, which need to be understood by each and everyone. So you can see here, if you want analog comparator digital output, okay, you need to configure these pins, any of these pins. Just to understand the example, you can say you can take a CAN. If you want CAN, you can configure over any of these pins, you can 0 to 3 or 4 to 7, whatever, and configure the registers and have the output. So you define your application first, right? And you know which pins you have connected in the schematic. Even while working on the schematic, it is very important that the hardware design engineer need to go through the pin muxing table and then configure the microcontroller functionality. If you have a fixed firmware team, or you can ask them to give the inputs. But if you are working standalone and you're the sole owner of everything, then you need to use the pin muxing option that is present in the Simplicity Studio. And you can see here, if I remember correctly, we have seen somewhere here, right? See in the Simplicity Studio somewhere, we'll just show again. So where there is a pin muxing option that is available. So using that pin muxing option, what we can do is we can configure the pins based on our requirement. So definitely, nowadays all the you can this is the one hardware configurator. Okay, pin and crossbar configuration tool for 8-bit MCUs. We will explore that and see how this is working for EFM32GG12. But that's one of the tool where you can decide which pin to connect to what for a given functionality. So these three tables, one is basically the functionality table, and then alternate function table, and ultimately the block diagram. All these are very, very important to understand from this specific datasheet. Apart from this, there are many things to be known, but hope this gives you a brief of where to look and what to look, and how are the internal things in EFM32. We will explore few more things from the datasheet while working on the interfaces. Hope we could give you some information on the microcontroller. Engineers have to understand that if you are having a very good knowledge on one microcontroller, that same knowledge can be carry forwarded to any microcontroller, because ultimately the slightly the features might vary, or the register names might vary, but ultimately the implementation wise it doesn't vary. And especially when you come to the register set and core related functionalities, if you are using the same ARM controllers, when you go inside the different microcontroller implementations, and you go deeper into the register sets, you see that you feel comfortable using them. So get a grip on so important advice to the beginner students is get a grip on one of the microcontrollers, deep dive into each and every point, and get to know what is happening, so that it helps you to understand the things better, and you can feel easy to use any of the microcontroller that is available in the market.